Well, hello and welcome, everybody. Hey, this lesson is the stuff you really need to know before you dive into quadratic equations. So if you're a student, I'd highly suggest that you pause the video. In the description, you'll find a link to some guided notes. This is the first page. There's also some practice in there. We're going to cover all of it step by step in this video. You can go step by step, hand in hand through the whole thing, record your learning. Really can help you out. So go ahead and do that now because we're going to dive in. So in this lesson, what we're going to do, we're going to talk about all the basics, the big ideas that you have to have under your thumb, under your belt, in your hat, in your head, so that you can be ready and successful with quadratic equations. You ready? Let's dive into it. So first thing first, what is a graph? Go ahead and take your best guess. I'm not going to go ahead and spend a whole minute on this, but think about this for a second. Learning's not a passive thing. You got to try some stuff. Think, which one of these is a graph? A, B, or C? All right, let's talk about it, shall we? So, turns out, graph is a visual representation of all the solutions or the ordered pairs. It's a picture of all the answers. So this is a coordinate plane, and on a coordinate plane we draw a graph. Just like a canvas is something we paint a picture on, but a canvas itself is not a picture, so that's not a graph. That's a coordinate plane. Now this parabola, if there was some more information, well, it could be a visual representation of all the solutions to a quadratic equation, but man, we don't have enough information, and the same thing with the line. So if you took the parabola and had it drawn on a coordinate plane, it was 100%. Can't argue it. That's a graph. Or if you took a line, that would be a linear equation. See? So in your guided notes, the very first question right there, what is a graph? Go ahead and take a moment, answer that question, and then come back to the video, and we're going to start with the next part. You ready? Let's go ahead and pause the video now. Fill that out. We're going to get started. All right, next question. How do you find y? So you're going to be graphing quadratic equations. They make these weird shapes called parabolas, and it's a good idea at the very beginning to be using a t-chart. So how do you figure out what is y when you know that x is a certain value? So like here, for example, we have y equals 3x squared, and we want to know, what does y equal when x is equal to 2? Well, a couple big ideas to keep in your mind. The first thing is that the x is called the independent variable. You pick the number you want for x, you plug that in, do the math. The math tells you what y is, so the value of y depends on the value of x, so y is called dependent. X is independent, it could be whatever you think of, and plug it in, and then, depending on how the equation is written, that determines the value of y. Now, when we're done, we write our equations as an ordered pair, x comma y, like that. So all you got to do, if you know the value of x, is you just plug it in. I'll show you how right here. You ready? So we're going to start off with 3x squared. And what we do is everywhere you see an x, you put parentheses, and you're going to plug 2 in right there. So you have 3 parentheses squared, so 3x squared. Get rid of the x, put the parentheses. If there was more than one x, you would put parentheses everywhere you see an x. And then you replace that parentheses with the value that you want to plug in. And from there, you just follow the order of operations. You have to square before you multiply. PEMDAS, right? Exponents before multiplication. So 3 times 2 squared. Well, 2 squared is 4. So 3 times 4, well, that's 12. So our answer is 2, 12. Now, there's one in your notes. It's not the same exact question, but why don't you go ahead and try that one right now? You can pause the video, try it, and then when you're done, come back and see how you did. All right, here we go. I'm going to show you the answer. So, again, learning is not a passive thing. Let's see. Ready? Did you plug it in and get 2, 4? I hope you did. All right, so we're going to move on. Next part. We're going to talk about all of this stuff here now. You ready? So what is f of x? That can be a little bit of a confusing thing. Maybe you've not learned about function notation yet. Well, good thing is you don't have to be a master with it. You just have to understand a couple little things. First of all, you're going to see stuff written like this. It says the graph is the function, it's the graph of y equals f of x. Well, kind of says what f of x is right there. F of x is just y. It's a fancy way of saying that y is the function of x. So y's value is dependent on what x was. That's all it means. So all you need to do is plug in the value for x into the equation and you figure out y. That's what this notation really means. We call it f of x like that, but they're the same thing. So if you see f of x equals x squared, don't freak out. It's the same thing as y equals x squared, essentially, for what you need to know right now. So you can treat them as though they're the same. Just plug in your number, do what you know. All right, let's talk about a couple things about this, right? So the points that are on this equation, they're all solutions. Sorry, the points that are on this graph, they're all solutions to the function f of x, or the equation y equals whatever it is, right? Means the same thing. So every point on here is a solution. So like negative 0.5 and negative 2.75, those are solutions to some equation. I don't know what the equation is. It's just called f of x. But all of these points, even the ones that aren't listed, they're solutions. Anything that's not on the graph is not a solution. So what about 1, 2? Do you think that would be a solution to this function? What do you think? Go ahead and pause the video, think about that, write down your answer. Is 1, 2 a solution to the function? Well, let's find out now. You ready? So 1 for x would be somewhere over here, and 2 would be above the x-axis, so that would be up there somewhere. That is definitely not on the graph, so the answer to that is definitely not. 1, 2 is not on the parabola, so it's not a solution to the function. For sure, for sure. All right. Now, what does y equal when x is 2? Let's see if we can learn how to read one of these graphs and really make sure we understand what it means when we say a graph is a picture of all the solutions. So what is y when x is 2? All you got to do is you got to remember that when you see, like, for example, 4, negative 5, that means x was 4. Somebody plugged it into the equation, did the math, and that was the answer. So all we have to do to answer this question, to find out what y is when x is 2, we just have to find x, where it equals 2. Well, that's right there. So somebody plugged in 2, did the math, they found out it equaled negative 9. So there you go. Now what about the input value? What was the input value that produced negative 2.75? That's kind of a confusing question. Well, input value means x. So this is saying what was the x that made negative 2.75? Well, that would be the dependent output, the dependent variable. So that would be y. So this is saying what does x equal when y is negative 2.75? Well, those two are paired up right here. This is the output, negative 2.75, and the input was negative 0.15. Pretty cool, right? So that's all you got to do to read these graphs. Every single point is you can think of it as x, the first number, was plugged into some equation, the math was followed, and the answer was this y value. So somebody plugged in negative 1 and the output was 0. Somebody plugged in 4, did the math, negative 5 was the answer. That's how these work. It's a picture of all of them. All right. Now, a parabola, this is a parabola. It's a curve shape that is created by all quadratic equations. Now, a quadratic equation is an equation that has a biggest exponent of 2. Maybe you've seen them written like this right here, like ax squared plus bx plus c. You've definitely done, if you're learning quadratic equations, you've done factoring, you've done multiplying of polynomials to get stuff like that. But if the biggest exponent is 2, it's a polynomial with the biggest exponent of 2, then you're dealing with a quadratic equation. Okay, so they all make a shape like this one that you see on the graph called a parabola when they are graphed. So let's talk about the important parts of a parabola so we can be familiar with them, right? So the very first part, the most important one we're going to learn about is called the vertex. That's the lowest point on a graph or the highest point. It's where the whole thing turns around. So here, the vertex is to -9. Because if you look here, it's going down, 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 and then it stops going down and turns around and goes up. Where it turns around, that's the vertex. It's a very, very important part. I'm going to spend a lot of time in the future learning about that. Now, through the vertex is this very important feature called the line of symmetry. It's actually not part of the graph because it's not got solutions on it, except for right here. It's a feature of the graph, kind of like the y-intercept and the x-intercept are features of the graph. But the line of symmetry is kind of like the mirror. On the left is a reflection of what's on the right. There's some symmetry here that's really cool. The line of symmetry, it passes vertically right through the vertex. Next up, we have the y-intercept. We know the y-intercept has a 0 value for x because every coordinate on the y-axis has a 0 for the x-coordinate. That's pretty cool. So there's one of those. There will always be one y-intercept. There will always be one vertex. It's right there. Now, the x-intercepts. This equation has two of them. X-intercepts have a 0 for the y. So 5, 0 is an x-intercept. -1, 0 is an x-intercept. Even if we didn't see this x-axis drawn, we would know that this here and 5, 0 here are both x-intercepts because they have a 0 for the y-coordinate. Now, this equation has two of them, right here and here, but sometimes there is only one x-intercept, and some parabolas don't have any x-intercepts at all. So, if you haven't done so yet, go ahead and finish answering all these questions right here, filling out this part of your notes right here before we move on to what's next. All right? All right, so now, page 2. Let's talk about how to use a t-chart. So, here on the left, we've got x in this column. That is where all the input values are written. And at the beginning, for this first part, I will make sure that in all the examples that are being used here, I'll pick good numbers for you so they work out nice and pretty, and there's going to be some symmetry, and the math will work out okay. And there in the middle, oh, that's where you're going to do all of your work. On the right-hand side, that's where you write all of your answers. So this one will be -2, comma, whatever y was, -1, 0, 1, and there would be one more for 2 right here. So these are the inputs. This is where you do all of the work, and here's where you write your answers. All right, so let's go ahead and do that. First thing you're going to do, right? F of -2. That just means you're going to replace x with 2, do the math, and see what y equals. We say f of -2, and that's all it means. Take that x, replace it with y. So start off, write your equation, but instead of writing an x, just parentheses. If there was more than one x, you'd have 2 parentheses. Go ahead and take the input, which is -2, and plug it in, and then just follow the order of operations. So -2 squared is -2 times -2, that's +4. All right, so now we're going to write our answer as a coordinate, as an ordered pair. So we're going to take -2 for x, plug it in for right there, and the 4, which was the output for y, goes right there. So why don't you try this one right here? Go ahead and plug in -1, see what you get. I'm going to show you right now. So math isn't something you do just by, it's not something you learn by just watching, so go ahead and try it. All right, here we go. I got -1, comma 1. So there's my coordinate. Go ahead and pause the video and try the rest because I'm going to go ahead and do them right now. When I plugged in 0, 0 squared is 0, so you got 0, 0. Plug in 1, 1 squared is 1, so 1 for x, 1 for y. And when you plug in 2, 2 squared is 4, so 2, comma 4. This is what you plugged in. This was the answer. Yeah, check that out. There's a pattern. Look at this. Do you see it? Do you see the pattern? There's a pattern. It's going to be there. For all quadratics, for all parabolas, all parabolas have this pattern. This point right here is going to be the vertex. Let's go ahead and graph it so you can see. So when you put all those things on the graph, that's what it looks like. And when you make your shape, it's not a U, it's not a V, it's nice and curved, smooth and continuous. 0, 0 is right here. Let's go ahead and plot the coordinates on there. 0, 0 is right here. That's the vertex. Do you see? There's a pattern right there. Everything on the left is a reflection of everything on the right. So -4, 1, 0, 1, 4. That's how it's going to work. If you have that pattern going, you're going to be good to go. All right. Why don't you go ahead and finish the questions at the bottom of page 2? If you were in person, well, this would be where we would begin the next day. All right, so now, to help you to remember how this works, let's go ahead and talk about these 2 questions right here, which I'd like you to try on your own before you begin. But if you haven't done so already, go ahead and pause the video, try them right now. We're going to dive into the top one right here, right? This one right here on top, we're going to go ahead and dive into it. Let's go ahead and zoom in, see what it looks like. So here's what we've got. X squared minus 4, right? So first thing you do, rewrite the equation, but everywhere you see an x, you put parentheses. Then you plug in your input value, right? So if you're messing up these steps, you got a little confused, you can actually go and write these down on your notes right now. All right, so everywhere you see the parentheses, you plug in the input value, and then you just follow the order of operations. So negative 2 squared is 4. 4 minus 4 is 0. So our answer, we have to write it as a coordinate, negative 2, comma 0. Pretty cool, right? All right, do the same thing with all of the other points. Put the parentheses, do the math. Put the parentheses, do the math. Put the parentheses, plug it in, do the math. And then you go ahead and you put everything on the graph, plot them all, and go ahead and right now we're going to label them. Now, I went ahead and I put X's instead of dots, but it's the same thing either way. So negative 2, 0, negative 1, negative 3. We have 0, negative 4. That's going to turn out to be our y-intercept and our vertex. It's double dipping right there, working overtime, right? And then 1, negative 3, and then we have, of course, 2, comma 0. So when we would graph it, this is the way we would start. Boy, it's going to be ugly. I'm going to try to do it with my mouse. Oh, man, that's not very good at all. But you get the idea, right? Okay, so what is the vertex? Well, the vertex is this coordinate right here at the bottom. That's the vertex, 0, negative 4. That's also the y-intercept, 0, negative 4. There are 2 x-intercepts, negative 2, 0, positive 2, 0. So go ahead and put those all in the graph. And then if you compare that to our very first graph, do you see how it's different? Well, it's been moved down by 4 spaces. That is because of the minus 4 at the end. That's the only difference. The very first one was just x squared. Now we have x squared minus 4. Pretty cool. All right, let's dive into the next one here, shall we? Negative x squared plus 4. Let's do that one. Just like before, write your equation, put parentheses. In place of the parentheses, write the input. Then follow the order of operations. Now, you do have to be careful. Negative 2 squared, that's positive 4. But we have a negative out here, so I'm going to leave it in the parentheses so I don't mess that up. Negative 4 plus 4 is 0, so the first point, negative 2, comma 0. Doing the same thing again, being careful with my order of operations. This is what we get. Yeah, see, 1 squared is 1, but it's negative now, and plus 4 is 3. So just being careful with all those things right there. Let's go ahead and put these on the graph. And look at this one. This one's upside down of the last one. It's going down instead of up. Well, that's pretty cool. So our vertex is going to be 0, 4. Go ahead and graph this. Go ahead and draw your shape like this right here. It's going to be kind of ugly, but you get the idea. Go ahead and graph it. Draw your shape like that right there. This one, vertex is 0, 4. Same as the y-intercept once again. And look at that. Same x-intercepts as last time. So how's this one different from the last? Well, it's flipped over. And it's also been moved up 4 spaces from the very first one anyway. And the reason that is because of the negative 1. The leading coefficient, is negative 1. That means it's going to go down. Cool. Now, let's go ahead and do page 4 now, shall we? So page 4, the very top one says x squared plus 4x. So f of x is equal to x squared plus 4x. Let's go ahead and be careful here. Rewrite your equation. Everywhere you see an x, there are 2 of them here. Put a pair of parentheses for each one, and then plug in your number. So negative 4 squared is 16. 4 times negative 4 is negative 16. That makes 0. So the output was 0 and the input was negative 4. Do the same thing. Just do it all the way through. Just be careful. So negative 3 squared is 9. 9 minus 12, negative 3. And then once again, as you can see, just plug in all the numbers, do the math. There we go. I'm plotting all these points, just like this. Oh, that's interesting. So now it's a little different because on the first few we did, every single one of them, the vertex and the y-intercept were the same. But now the vertex is kind of off down in the third quadrant over there. That's pretty cool. And we have a y-intercept that's the same as the x-intercept. Remember, if x is equal to 0, that's a y-intercept. But if y is equal to 0, that's an x-intercept. So the origin, it's both. All right. So our vertex, negative 2, negative 4. Our y-intercepts, 0, 0. And our two x-intercepts are 0, 0, and negative 4, 0. Now, how did this one change? Well, it gets moved to the left and then down. And the reason that is because we have that new term over there, the 4x. Kind of cool. We're going to see how that works. Now, two more questions. I'd like you to try them both, right? So go ahead and try them, and let's see how we do here. All right. So we have x squared minus 4x plus 3. Everywhere you see an x, put a pair of parentheses, and then just plug in the number. Here we go. You can go ahead and check your work. If it's going too fast, you can pause the video and take notes. But by this point, I hope you got it, right? I know the equation changes a little bit, but all you got to do is follow the order of operations. So if we put all these things on the graph, this is what it looks like. Really similar to the last one, but here, our vertex and our x-intercepts and our y-intercept, they're all unique. There's not a single point that's doing double duty here, right? So our vertex is 2, negative 1. Our y-intercept is 0, 0, 3. Right here, two x-intercepts, 1, 0, 3, 0. Okay, so this one gets moved down 1, but over 2 spaces from the very first one. That's kind of cool. Now, the reason that is because of a combination of these two things right here. All right, almost done. 2 more questions to go. I said there were 2 on the last one. I apologize. I got a little ahead of myself. So on these last 2, again, math is not something you learn by just observing. Go ahead and pause the video. Try them on your own. If this takes you, a couple of days to work through, that's okay. You're going to get this. You're going to learn. Be patient with yourself. You're doing really good. You got this. All right. So now, our equation is 4x squared minus 1. Just like before, put parentheses. Plug it in. Do the math. We're going to go ahead and do that for all of them, right? Negative 1, put in a 0. So you square first, and then you multiply by 4, and then you subtract. Just like that, putting all those values on our coordinate plane. Now, this one's kind of strange because 15 doesn't fit. So on paper, you could put it way above. We don't have room here, so it's way off of the screen. However, we'll put it there for now and just see how it goes. Now, this is kind of strange right here because our graph is going to cross the x-axis, but it's not one of the points we found. Oh man, that's really ugly. Do you see? The graph crosses somewhere between negative 1 and 0, and then again between 0 and positive 1. So somewhere maybe around 1/2 and negative 1/2, maybe those are our two x-intercepts. Now, as we learn about quadratic equations, we'll learn how to find out exactly what those are, but for now, we're just going to have to kind of estimate, right? So this one is really similar to our very first equation, except it gets moved down 1, and it's really skinny. It's not spread out like the last one is. The reason it is actually because of the 4. The 4 right there makes it kind of skinny and narrow, and the negative 1 right here moves the whole thing down 1 space. Almost home. Last one. This last one's unique. It's very different from the others. Do you see? F of x equals 2 times quantity x plus 1 squared minus 2. Man, that's actually called vertex form. That's something we're going to learn about later. But just like before, everywhere you see an x, you put a pair of parentheses there. So right here, you're just going to put negative 3. So negative 3 plus 1 is negative 2. That's right. Just being careful with the order of operations here. So you have to do parentheses and then exponents, and then multiply and then subtract. PEMDAS. So negative 2 squared is 4. Now we can multiply by 2. 2 times 4 is 8. 8 minus 4 is 6. So when the input was negative 3, the output was 6. All right, doing the same thing with the rest. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 times 2 is 2. 2 minus 2, 0. All right. And finishing them up, go ahead and make sure you're doing this right. If you haven't finished this one, man, I highly encourage you to pause it and try it right now. So maybe you got a little confused and you didn't have quite enough confidence to just take that leap of faith. That's okay. Now you got a little support. If you haven't done these last 3 on your own, go ahead and try them right now. You should be able to see exactly how they work. I'm going to start it now. All right, so plug in negative 1. Negative 1 minus 1 is 0. Negative 1 plus 1, I should say negative 1 plus 1 is 0. So 0 squared is 0. 0 times 2 is 0 minus 2, negative 2. Doing the same thing with the 0 right there when we plug it in, and the 1 there when we plug it in. Right? So, putting all of these points on our coordinate plane, this is how our graph looks. Oh, that's kind of interesting. A little thinner than normal, but those are all of our points. You can put those on the graph now. Looks like our vertex is negative 1, negative 2. We have an x-intercept and a y-intercept of 0, 0, and another x-intercept of negative 2, 0. So our graph would be right here, looking like this. All right, so it got moved down 2 spaces and 1 to the left. That's because of this number, 1. And this number, negative 2 there. You're going to learn how those work for sure in the near future. So by the time you're done with this video, you should be able to do all of those things. You should know what the vertex is, the y-intercept, the x-intercept, what our parabola looks like, and how to graph one. I hope you did really well. You should be ready to go. I'm excited for what's ahead for you. You've got yourself set up to nail quadratic equations. Hey, until next time, I hope you have a great day.